Hey guys, this is Coach Brian bringing you your 6.8 notes. 6.8 and lesson 6.9 will be very, very similar. The difference, just like our last two lessons, will be that today's lesson is focused in degrees and next classes will be focused in radians. So this is going to be a lesson where we start to tie everything together from this unit. So you might have to dig back through your old notes and review them a little bit, but this is going to be putting everything together now. So for this first part, A through C, it says to use the angle 210 degrees. And we've got a little unit circle out here, so it's always helpful to go ahead and start with labeling it. And it would help if you did it correctly. 0, 90, 180, 270. Okay, those are kind of our easy ones to start with. And then if you go halfway between, we've got our 45, 135, 225, 315. And then we start counting by 30s. So we've got 30, 60, 90, 120, 150, 210, 240, 270, 300, and 330. So we've got our unit circle filled out, and specifically we are focused on the angle 270, and this is in standard position, so it's going to start on the positive x-axis. It's going to pivot or hinge, have a vertex at 0, 0, and then we can see it opens up here at 210. Okay, now the first question says what quadrant does this angle terminate in? And so we can see using our quadrants that this is in quadrant 3. Okay, so this is a Q3. Now, it says, what is the reference angle? Remember, reference is the fastest path to the x-axis. So when you're in quadrant 3, you want to take your standard angle and you want to subtract 180. So 210 minus 180 leaves us 30 degrees. It would be fastest route to go this 30-degree angle to the x-axis. And now, lastly, it says, for the 6 trig functions, circle if it's positive or negative. So this is where we need to remember our mnemonic, all students take calculus. Right now we're in quadrant 3, all right, which is T. T means that in quadrant 3, tangent is positive and its reciprocal cotangent is positive. Those are the only 2 positive trig functions in this quadrant. And so our remaining functions would all be negative. Now, we also have our special right triangles, 45, 45, 90, and a 30, 60, 90. It says to update these for the unit circle. If you remember, the unit circle is based upon a circle with a radius of 1. So it's like locked at 1, okay? Radius is locked at 1. It's not going to change. It's going to be 1 all the time, as long as we're dealing with the unit circle. And so when you're thinking about these triangles, if they were, and it's going to be hard to draw it to scale here, but if they were inside of a circle, okay, this hypotenuse would be my radius. I know that's very ugly, but the hypotenuse is the radius. And the radius is locked at 1. So that means we need to do something to this hypotenuse to make it equal 1. And we need to do something to this hypotenuse to make it equal 1. So when you have any number, if you remember this, any number divided by itself will give me 1. And now the special triangles are proportional. So if I'm dividing the hypotenuse by the square root of 2, it means I also need to divide the other sides by the square root of 2. And on my 30, 60, 90, if I'm dividing the hypotenuse by 2, I need to divide my sides by 2. And lastly, we don't want to leave these sides in this format, so we want to rationalize them. Okay, we want to rationalize them. And so what we get here is the square root of 2, and then square root squared. That will leave me with just 2. So both of these sides are the square root of 2, 2. So I hope that made sense to you. All we didn't change the ratios or the proportions at all. All we did was manipulate them to make the hypotenuse equal 1. The hypotenuse needs to equal 1 because on the unit circle, the hypotenuse is the radius and the radius is locked at 1. So if we were graphing, all right, think about it like this. See how this angle right here is 30? This one's 60. This one's 45. Think if we were putting that onto quadrant 1. For instance, if this was our 30, we would look up here, and eventually with enough practice you'll learn this. Our hypotenuse is 1. This short side is always half of the hypotenuse on a 30, 60, 90. And then the medium side, if you remember this, is x root 3. So if you have 1/2 times the square root of 3, you get square root of 3 over 2. That's where that comes from. That's if the 30 is theta. If we move over here and we put our 45 as our theta, on a 45, 45, 90, remember the sides are the same. So if the radius, the hypotenuse is 1, our sides are square root of 2 over 2. And lastly, if we rotated, see if we took this 60, if we rotated this and we had the 60 down here, that would put the 30 up top. We would have our hypotenuse of 1. Our short side is half of the hypotenuse, and then our medium side is x root 3. Okay, remember your proportions and your ratios. So, square root of 3 over 2. Those are the 30, 45, and 60. And those are helpful because if we go back to our unit circle, see how the main triangles up here are 30. Sorry, not a good line. 30. If I went straight down from there, I've got my right triangle. We've also got 45, 45, 90, and then we've got 60, 30, 90. So you can see how our special triangles that we've learned so much about this year actually make up the quadrants of our unit circle. If I flipped it over, that's where the 120, 135, 150 come from. It's like a reflection. And same thing for quadrants 3 and 4. So what we're talking about today is finding our exact value. So we're putting it all together. We're putting SOHCAHTOA together with the special triangles, and we are finding the exact value of the sine, cosine, tangent, and the reciprocals of these specific angles. So some important things to remember right here, and this is all, again, earlier in Unit 6. We talked about sine, which is, if you have sine theta, it's opposite over hypotenuse. But if we're talking in terms of these angles, like when it's graphically laid out, your opposite is your y, your hypotenuse is your r. So we would say that our sine is y over r. And then for cosine, it's adjacent over hypotenuse. But again, if we zoom in on any one of these, the adjacent side is our x, and our hypotenuse is r. So we would say that it is x over r. And then lastly, when we have tangent of theta, that is opposite over adjacent. And if we go look up here, opposite is our y, adjacent is our x. So if it's opposite over adjacent, we could say that it's y over x. Now, one thing is that when we're dealing with the unit circle, r is always 1, okay? On the unit circle, for unit circle, r equals +1. Okay, for the unit circle, r equals +1. So let's graph and find what these are. It says to rationalize when necessary, okay? So let's start with sine 30, and I'm not going to do all of these. Let's start with sine 30. Sine 30 degrees is right over here in quadrant 1, okay? We'll say that this is 30 degrees. And if I put my theta right there, and if I just drop the line straight down here with a radius of 1, I could recognize that this is a 30, 60, 90 triangle. And when I have a 30, 60, 90, my r is 1. My short side, okay, my short side is half of my hypotenuse, and my medium side is x, or excuse me, in this case, it would be your short side times square root of 3. Sorry, I'm using the wrong pen for this, which would equal square root of 3 over 2. So I've got all my sides right here. This side's 1, this side's 1/2, and this side's square root of 3 over 2. Now, it asked me to find sine. Sine of theta is y over r. So let's look at this. Our y value is opposite. So it's 1/2. Our r is always +1. So 1/2 divided by 1. Any number divided by 1 is itself. And so what we would say here is we would say that the sine of 30 degrees is 1/2. And if you, again, like I've tried to explain a lot in class, if you're wondering, what does this number even mean? It means that the opposite and the hypotenuse have a 1:2 ratio or proportion. And if you look at this 30, 60, 90, see how this is half of the hypotenuse? That is a 1 to 2 ratio. That's a 1 to 2 ratio. So that's what we're actually finding here is the ratios of these sides. Let's try a couple more. Let's try a couple more before the bell rings during my video here. Let's look over at cotangent of 150. So if I go over here, 150 degrees falls in Q2. 150 degrees. And that has a reference angle, okay? A reference angle of 30. So this again forms a 30, 60, 90. And if my R is always 1, my short side is half of my hypotenuse, and my medium side is the short side times the square root of 3, I've got my 3 sides again. Now I just need to know what cotangent is. Cotangent is the inverse of tangent. Another way of saying that is it's tangent, which is y over x, flipped. So cotangent of theta equals x over y. So I just need to, for cotangent of 150, I just need to find my x right here. Now I did forget one little detail about this. It's negative because I had to go left. So it's negative square root of 3 over 2 divided by my y, which is positive 1/2. Now remember, when you are dividing fractions, you want to keep, change, and flip. So you would keep your first one, change your operation, and then flip your second fraction. And so negative 3, negative root 3 times 2 is negative 2 square root of 3. And 2 times 1 is 2. And if you look, these 2's cancel out. And so my answer is the negative square root of 3. That is the exact cotangent of 150 degrees. I'll try one more before I get caught here. Let's go to sine 210. We started with 210 today in our warm-up. So we'll go over here to quadrant 3 where 210 is located. 210 has a reference angle of 30. So this is like a 30, 60, 90. I guess I should have picked a different one since I wouldn't do all 30, 60, 90s. On a 30, 60, 90, the hypotenuse is 1. The short side is half of the hypotenuse, but let's look. It's going down, which means it's negative, and the medium side is the short side times the square root of 3, but look, it's going left, so it's negative. So sine is opposite, or y, over the hypotenuse. Any number divided by 1 is itself. So the sine of 210 degrees, exact value, is negative 1/2. There's a lot more examples on here for you to try yourself. Try to complete those before moving on to part 2 of the video.